This is our fourth example of using the force of friction equations and finding coefficients of friction. A car initially traveling at 27.3 meters per second skidded to a stop. The length of the skid mark was 158.8 feet. Find the coefficient of kinetic friction between the tires and the road. So it's always important to start with a picture. So here is my car, and this looks like an initial velocity, 27.3 meters per second, and it skids to a stop. So later the velocity must be 0. And this looks like a displacement. So I can tell right away I have some kinematics information. So my list of variables for kinematics includes these quantities. So 48.4 meters, 27.3 meters per second, 0, and I don't know the acceleration or the time. I can see this problem also involves forces, so a free body diagram would be the next step. I know there's a force of gravity pulling down on the car, surface is pushing up on the car, and let's see, there are no forces moving it forward, but it's slowing down because it's sliding. And sliding is kinetic friction. So there must be a force of kinetic friction opposing the motion of the car. So I can see from my force diagram, my force and motion models, that I have unbalanced forces. And there must be a changing velocity, which means that it's accelerating, which fits what I know here because I know it's slowing down. Slowing down is an acceleration. And I'm supposed to find the coefficient of kinetic friction. Well, what's that related to? Coefficient of kinetic friction, that's related to the force of kinetic friction and the normal force. So this relationship might help me find the coefficient of kinetic friction. So I'm not really sure how this is all going to work, but I will start over here because it looks like I could find the acceleration. So even if you can't tell how you're going to finish a problem, you could probably find somewhere to start, and then usually the other steps become more clear along the way. So I want to find the acceleration. I don't know the time. What equation would that be? That's going to be vf squared equals vi squared plus 2a delta x. So putting in my vf and all the variables, and go ahead and work that out. When you're finished with the algebra, you should arrive at the acceleration of negative 7.7 meters per second squared. Does this make sense? The negative makes sense because it is slowing down in the positive direction, so the velocity is becoming less positive, so this does make sense. Okay, what am I going to do with the acceleration? Well, acceleration is related to forces through Newton's second law. F net equals ma. So if I know the net force, some expression for the net force, maybe I could do something with this. Looking at my diagram, the vertical forces are balanced, so the net force is only this force of kinetic friction. So when I put my forces in for the net force, I always do the forces to the right, which is my positive direction, minus the forces to the left, the negative direction. So there are no forces to the right, so nothing, minus the forces to the left, which is the force of kinetic friction, equals mass times acceleration. So the negative of the force of friction. Okay, mass. I don't have a value for mass. So since I don't know what the mass is, in that case you just leave mass in there and hope that it goes away later. And solving this for force of kinetic friction, we have 7.7 times the mass. Now we're ready to move over here because this relates to this. And so we can substitute that. So 7.7 times the mass equals mu k times the normal force. We need to know the normal force. Vertically, the forces are balanced, so the normal force must be equal to the force of gravity. And force of gravity I know is m times g. So that's what we're going to put in for the normal force because these are equal. So I don't know the mass. So substitute the word mass for mass and 9.8. And now we want to solve this for the coefficient of kinetic friction. Now this is interesting. Look, mass is on both sides of the equation. So I could divide both sides of the equation by mass. And voila! It goes away. So we didn't actually even need to know the mass. Solving this for the coefficient of kinetic friction, we get 0.79. So this is an example of a force problem where you're given kinematics information, and this is where you start. You start with velocities and distances and times, then working with Newton's second law to find something about the forces, and then getting finally to the friction, force of friction equations.